So how many people here have heard of MailChimp? Okay, so you know that we have a lot of giveaways and stuff. I'm going to do that as well. I'm going to go through a lot of examples. I know it's late in the day, so your prizes for class participation is you'll get one of our little action figures. And we have a ton of more swag here, so if we run out of time, I'll just throw them at people. All right, so I'm going to start off, we're going to talk about how we do continuous deployment of Puppet modules at MailChimp. First off, I'm Bill O'Neill. I'm pretty much W. O'Neill on Twitter, GitHub, any place where you can get a name. And that's pretty much my wife. That's she doesn't listen to me much, except I did make her listen to my presentation last night, and she knows nothing about Puppet, and I still think she knows nothing about Puppet at this point. So hopefully you guys will by the end of this talk. My career has always been as a sysadmin for development groups, which is kind of a neat role now that we're getting in the world of infrastructure as code. Just some more background. I've been Red Hat certified since Red Hat 7. That is not Red Hat Enterprise 7, Red Hat 7. So I'm very excited that my certification is now looped around in its current again. I've been Puppet certified since 2013. I lucked out and going to PuppetConf 2 years back, and they were giving away the free tests. It is a lot harder than you would think. The example test is very easy. The actual test is very hard. So I'm going to go on a little rant about DevOps here. The way that most people talk about DevOps is that it's developers and operations talking to each other. I think that's common sense. If you're in a business environment where different groups aren't talking to each other, you have a bigger problem than whether your devs are talking to your operations. So when I hear about DevOps, I think of how can us as operations folks, and then from what I remember from someone else's presentation was that most of the people in this room have a sysadmin background. Only a handful of people consider themselves developers. Is that true? How many people here are sysadmins, would label themselves as sysadmin? Okay, and how many people label themselves developers?
Can we be both?
Or both, yes, everyone's both now. So developers, for a long time now, they've been crafting their work and making it more like engineering than throwing code against the wall. So they've been coming up with things such as unit testing, documenting code, peer review, pretty much all the things that make it an actual practice versus an art form. And I think systems administration has finally got to the point where we're learning those same techniques and taking the techniques that developers have used to make it a practice, and sysadmins are using it to make infrastructure as code a practice as well. So to me, that's the beauty of DevOps. Okay, so again, I work at MailChimp. This is our mascot, Freddie von Chippenheimer III. I don't know what happened in 1 and 2, but he's the third. And what we do is we're an email service provider. Pretty much, we will deliver mail for lots of people. In fact, if you're one of the Puppet test pilots, when you get the emails, they're actually coming through us, which is pretty cool. So we deliver about 500 million emails daily. And that's about average. Sometimes we do more, sometimes we do less, but on the average we do 500 million emails a day, which is a lot. On Cyber Monday this year, we delivered 723 million emails. I think at one point we're delivering 50 million emails an hour. And we have a sender score of 97. If you're not familiar with the email service world, the sender score is kind of like the credit score of how well you do delivery. It's up to 100. And it's the likelihood of, if you're sending an email through us, how likely is it going to get into somebody's mailbox. So you want to make sure that it's not marked as spam, it's not bounced back, that whoever you're delivering it to could be Gmail, or it could be a little mom and pop ISP. You want to make sure that the mail is getting to the inbox. And so there's a third party that manages sender scores for the provider such as us, and we have a score of 97, which honestly blows everyone away. If you want more stats about what we do, you can go to delivery.mailchimp.com. I know you can't click on the slide right here, but my slides will be posted on the Puppet Labs website, and I also have a link at the end to the source code for the slides. All All right, so I'm going to talk about the history of MailChimp in general. We started off by accident, pretty much. Our founders were web developers, and they made this little side project for sending email for their web development customers, and soon they realized that it was more profitable to deliver the mail than to do web development. So as a result of that, since they weren't systems administrators, they did a lot of hosted providers. And how many people here are familiar with the idea of using, treat your servers as cattle and not pets? Okay, so not too many people. So the idea behind that is, when you have a pet, you treat it very well. You baby it, you make sure it's well fed and taken care of. It gets a lot of attention. You don't just leave it in a cage and go on vacation and forget about it. Whereas cattle, it's the opposite. Cattle just have little tags in their ears. If one gets sick, you shoot it in its head, put it out of its misery. And that's how you want to treat your servers. You don't want to baby your servers. You want to have them replaceable. If they get sick or something goes wrong with it, shoot it in the head, bring up a new one. So to take the analogy to the extreme level, because we went through a lot of hosting providers and had some issues with them, we went through a lot of cattle drives, moving from hosting provider to hosted provider. So at some point we figured out that doing all these migrations, that configuration management is hard. It's one thing to set up a server once. When you have to set up a server multiple times because you're moving providers, you want to make sure you do it at the same time all the time. And so it got to the point where some of our operations guys and developers, they started looking around for a tool to manage all this. And they came up with this idea that, well, Chef and Puppet and CF Engine, they have a high learning curve. We don't want to learn this DSL. It's crazy software. There's not many recipes out there. And we're kind of a small company. We don't really need to deal with this. So what was their solution? Write their own tool to do the same thing, because that's the developer mentality. Let's write another tool to do that. And this tool served very well. We actually have a couple servers that still use this tool internally because they're still a hosting provider. But then we got to the point where we decided to move to colocation because we had grown so big that we were tired of doing the cattle drives. We had hired enough people in our operations staff to manage the servers ourselves and manage them well. And we wanted to manage our own destiny. If the server broke, we wanted to fix it ourselves rather than having to open a ticket, rely on somebody in a data center on the other side of the coast perhaps to swap a hard drive. And if anybody that I've worked with before who's gone through change management process and I've argued with them about why do you need change management on a swapped hard drive in a RAID array, I apologize because now I found out that there are companies that cannot do that hard drive swap reliably. But we can. So the idea behind moving to colocation is we wanted to buy the car instead of lease the car. When you lease a car, you have a lower upfront cost because you're paying so many $100s a month, but you're paying that infinitely. You never pay the car off because you either have to trade it in or you want to get the new model. But if you buy the car, your payments are higher up front, but eventually you pay it off, and then you start getting cost savings. And that's what we found out with colocation. We found out that once we factored in the cost of the additional staff, the networking, the space, we had the expertise, and using a tool such as Puppet to manage these servers reliably, it made more sense to own the servers ourselves than to use a hosted provider or even a cloud provider. All right, so we grew our operations team, and again, when we were moving stuff around during these cattle drives, the big thing we needed was a tool with a dry run mode. And that was the big problem with the internally built tool. There was no way to test new code or even test moving a server, maybe with new IPs or new DNS servers. And again, when we're looking at other tools, I think at the time Chef didn't have it, CF Engine didn't have it, but Puppet did. And there's some arguments about whether there is such a thing as true no-op mode, but Puppet gets pretty close to it. I mean, if you run it in Puppet apply -- no-op, you get a good sense of what's going to change, or if nothing's going to change. And so that was a big win for us, picking a tool that could do that. All right, so we start off with an operations team of one guy. So when there's one guy who's in the operations team, if he makes a mistake, pretty much only he knows about it, unless it's a really big mistake. But as we're growing, you get more people in your team, and that amplifies how many mistakes you make. So the issue now becomes, how do we catch these mistakes as early as possible? And in an ideal world, everything would be automated. That's the ideal world. Really, we kind of took the idea of automation, which is similar to automation, and that's something that came out of the Toyota assembly line model. And it's the idea of automation with a human touch. It's that you try and use computers and automation to simplify things as much as possible and catch errors, but at the same time, you don't make it all hands off. You have somebody kind of watching things and ready to pull the emergency stop switch if need be. So the way that Toyota came up with, pretty much summarize this whole automation process is, number one, you detect the abnormality, then you stop the abnormality, stop the pain, and then you go and fix or correct the immediate condition. And so what do you think is the best time to fix an issue with a car in the assembly line? Is it at the very end when it's about to be shipped to the dealership, or is it in the beginning of the assembly line when there's maybe like 2 bolts in the bumper that you need to fix?
Beginning.
In the beginning, right. So that's the process we came up with. We wanted to catch mistakes as early as possible and continue checking for the mistakes so that we don't get to the end of the line where we're deploying a server and realize, oh, we left the firewall rules open and anyone can SSH into those. Okay, so again, how do we catch these mistakes as early as possible? We do a combination of using DSL tools. And I'm not familiar with what DSL means. Okay, good. Just to go over it again, DSL is a domain-specific language. So Puppet is a domain-specific language. Some of the other tools surrounding Puppet, such as, languages within Puppet, such as YAML and ERB, they're also domain-specific languages. And there's tools that make it easy to catch mistakes within those files. We also go with editor support, source code management, and continuous integration. So these are pretty much all the things that all the previous speakers have talked about as well. You want to have your editor catch mistakes if possible. You want your source code management to catch mistakes, and use a continuous integration tool to catch your mistakes. So each of these kind of leverage on the work of the previous one. And so I'm going to cover some examples of how we implement these. Okay, so DSL tools, very first one is Puppet. Also within Puppet, you have ERB, YAML, and then the Puppet style guide. It's not really a DSL tool, but there are some tools that help you implement the Puppet style guide. All right, so with Puppet, you're writing your manifests and you want to check the syntax of it. You can, has a tool built in for it. You just run Puppet parser validate, the name of your manifest or Puppet file, and it'll tell you if it's syntactically correct or not. All right, so first class participation here. What is wrong with this Puppet code?
Mode.
The what?
They said you needed the sticky bit on mode before.
That's a style guide thing, but it's not really a syntax error.
There's a comma missing after the notify.
Very good. Who was that? Nice eye. I was kind of hoping people would pick up on the comment, but the comments are another example of it's syntactically valid, but it's not considered best practices. So if you run Puppet validate against this, it would come up with a syntax error, but not really in the place you expect it to be. So it's complaining that it's on the require line. So if you go back in the require line, it's thinking that the error is here. The error is really up there. So yeah, we've used an automated tool to pick up that there is an error in the file, but you still need a human to look at this and figure out exactly where the error is in the file. Okay, so ERB is kind of an ugly syntax here, but same thing. You run it against your template file, and it'll give you a yes or no answer, syntactically correct or an ugly error message. Next class participation. What's wrong with this ERB file? This one's a little bit more complicated. Any guesses?
Variable should be inside the curly braces for that service.
This one here? No, that's valid. It's actually, the unless doesn't have a closing emblem there. So who came up with this? All right, so if you run this through ERB, it comes up with the error that you're missing an N somewhere. And again, it's saying that it's on line 11 because that just happens to be 11 lines in this file. So again, automated process picked up that there's an error. You still need a human to go through and figure out what the actual error is and go fix it. Okay, so YAML. We actually have two different ways of checking YAML files. Anyone not familiar with what NPM is? So NPM, it's a node package manager. So this is a way to install a Node.js tool called JSYAML, which is a pretty good tool for parsing YAML. Another way to do it is if you have Ruby installed, which you probably do if you're running Puppet, you can just try loading the YAML file and see if it succeeds. All right, what's wrong with this YAML file? I'll give you a hint. It's in the ILO settings section.
The first colon is true.
Yeah, the SSH status import and HTTPS ports, they should have colons after it. You still got it. Okay, so again, we run this through the YAML parser, and I'll show you both ways of doing it. If you use the JSYAML, it gives you a bit more concise error. It's thinking it's on line 9 again. If you use the Ruby way, it also thinks it's on line 9, just at a different column position. So same thing, line 9 is global. Yeah, so it thinks that the error is here. The error is actually one line up. So again, kind of beating the point again. Home, you have the automated tool picks up an error. You need a human to actually figure out what the error is and how to fix it. Okay, so the Puppet style guide. If you're new to programming or just new to Puppet in general, this is actually a pretty good read. It explains the way you want to structure your code. It'll cover the module structure that previous people have talked about. It'll talk about the sticky bit mode on files, whether you want booleans to be quoted or not, and pretty much a bunch of good stuff. So somebody went and wrote a gem tool called Puppet Lint that will go through and check your code to see if it complies with these style guides. And it's probably a good idea to follow this anyway so that everyone is on the same page in terms of how your Puppet code is constructed and what it looks like. So the way you run that is you do the gem install to get the tool installed, and then you run Puppet Lint against either a particular file, or if you give it a directory, it'll do it across all the files in the directory. And that's pretty cool, but it has an even better feature. You can pass in the -- fix flag, and it'll actually fix most of those errors for you. Okay, so this is the original one with the comma in place. If you heard people earlier today talk about the trifecta or the golden rule 3, I forget what the actual nomenclature is, but this is pretty much it. It's you have a package file on the service. So syntactically correct, but what could be wrong style-wise, guy? I kind of mentioned 2 already. The mode, it's 3 digits instead of 4. The comments aren't really right. Anything else that might be a little off?
Too long, notify statement.
Yeah, it'll flag the too long.
Trailing commas?
I don't think it does issue with trailing comments, actually.
Aren't all of the arrows supposed to be lined up?
Right, the arrows should be followed up, or lined up. What else is there? How about these booleans?
Shouldn't be quoted.
Right, they're quoted, so they might be evaluated as strings instead of a boolean. So if you run Puppet Lin against this, it picks up all these. And Puppet Lin is actually really good about telling you exactly where it is. The lines and the errors it gives you are mostly dead on, which I think is why you can do the fixed flag most of the time. So if you go and do the fixed flag, it actually fixes all of those errors for you. So it takes off the quoted Boolean, quotes around the Booleans, it aligns your the arrows for you. It changes the comments to the hash marks, and it changes the octal value of your symbolic code. So this is what it looks like after the fact. Still, the comments are a little off, but it still looks a lot better than the original one, and it'll pass the syntactic guide. This gives you a little bit better idea of the actual diffs that it's doing. So it took it aligned the here, it changed the quotes, and it unquoted the Booleans. Any questions about these tools so far? So these are really good tools. They're great for standalone, but who wants to go and run a standalone tool every time you're running or writing a Puppet manifest? So what we try and do is we build it into the editor. Most of our group are Vim users, except for our VP, he's an Emacs user. I'll talk about that in a little minute. Just to do the whole editor battle, how many people are Vim users? And how many people are Emacs users? Anyone use anything besides Vim or Emacs?
A lot of Nano.
VI, Vim, same thing. Pico? Anyone use Pico?
A lot of Nano.
Nano, okay. All right, so we use Vim, so the main thing with Vim is the plugins. There's a lot of great plugins to make Vim essentially an IDE. So we'll use the Syntastic plugin. Syntastic is a great one if you're a Vim user, just in general, because it won't only work on Puppet, it'll work on Perl, Ruby, Python, do a lot of syntactic checks. And so that'll actually take advantage of, if you have the Puppet Lint and JSYAML and Puppet itself installed, it'll run all those checks on your code as you're editing it. So Vim Puppet is another plugin that's really nice. It'll try and make those arrows line up for you as you're typing them. A couple other things where it'll try and make stuff align with the style guide as you're writing it, rather than having to write a tool prior to the fact. And then I just learned about this while I was making this presentation. There's something called util snips, and then something called Vim snippets. Sounds really neat. I haven't tried it myself, but I suggest if you're a Vim user looking into it. It lets you have essentially code stubs. So if you start writing a file resource, it'll pre-fill out the brackets and the alignments, and you just tab through different places and fill in the code as needed. All right, so Emacs. I can't use Emacs to save my life. I can't even quit out of Emacs. But our VP uses it, so you got to support the VP. So this is a resource he found that talks about some ways of setting Emacs up. Somebody earlier mentioned Geppetto. Any Java coders in the room? Or people who use Eclipse? Right, so if you use Eclipse, you'll probably be familiar with Geppetto. Geppetto is a really nice IDE. It's built on the Eclipse framework. So that's already something familiar to you. Geppetto can either work as a standalone IDE, or you can have it be a plugin to Eclipse. All right, so we've got the DSL tools handled, we have the editor handled, and flag the errors as you're going along. So the next stage is source code management. Anyone here not use source code management for Puppet? Okay, that's good. I think pretty much everybody who spoke today mentioned using commit hooks along with your source code. One way that MailChimp is unusual that we don't use Git, we actually use Mercurial. A lot of that is a historical aspect because our main code base is written in Mercurial, so we took our Puppet code and we wrote that in stored in Mercurial as well. But Mercurial, as well as any other tool, they all support commit hooks. So we'll have a pre-commit hook that will run those same checks against new code that's being checked in, and if, say, somebody's been running Pico or Nano, and they don't have a plug-in to check the code as they're running along. When they get to the point where they're committing code, it's going to flag it, and you can stop that at the gate. So we actually have one of our NOC users, our NOC administrators, he brought up an entire stage of servers where we have to go through and we have to edit the higher configs to set up IP addresses, new users and passwords and all that. And I told him I was going to say he used Pico, but he actually used something else, I forget what. But he didn't have the Puppet tools installed. He's obviously running an editor that isn't going to flag these. So when he went to go commit it, it flagged any errors he had. Fortunately, he only had a handful of errors, and it was quick for him to figure out what it was and get them fixed. So another part of source control that's really a big win for us is peer review. So all these tools are going to check whether something is syntactically right, but it's not going to check if it's the right thing to do. And that's kind of where the business logic type stuff comes in. So this is an example of a peer review that I submitted. Anyone not familiar with the idea of peer review? Okay, so peer review, if you're not familiar with it, it's pre-staging your commit somewhere where your peers can review, and that's peer review. So we use a tool called Review Board. And so you put in your commit, and you give it a summary and a description, and you have your peers look at it. Hey, is this the right thing to do? Should I do it somehow differently? And so I got feedback that said, well, maybe you don't want to notify on a class Apache service. You want to have the config file notifying the exec. And that was a great feedback, because if I committed that as it was, every time we would edit this one particular config file, our Apache server would restart rather than do a reload. So that was a big win for us. So you go and you review your code, and then you stage it, and then it goes through the same process again. Now this is another way that we kind of differ from what some previous speakers have talked about in terms of branch-based development. We use trunk-based development. We actually use two different repos. We have a dev repo and a production repo. So we'll go through and we'll do our development in the dev repo, going through using the DSL tools, using the editors, support, using the pre-commit transactions, but we always deploy based on the trunk. And the way we do that is we'll cherry pick commits from our dev repo onto the production repo. And the production repo has those same pre-commits as well. So if you try and to cherry pick a commit and you make a merge mistake, the commit hooks are still going to pick that up and flag that for you. Okay, so at this point, when you have your code in a source control tool, continuous integration is pretty easy at that point. We haven't used Jenkins. If you haven't used Jenkins before, it's really easy to set up. There's a lot of other tools besides Jenkins, but pretty much the idea is that anytime something changes in source code, you want to do another build against it. And by build, I mean running those syntax checks against it. So run Puppet lint, Puppet syntax, Puppet validate syntax, and the ERB checks. This guy, I think he works at Jenkins, or is part of the Jenkins project, I'm not sure, but he has a bunch of scripts that already handle this kind of configuration. So what we do is we clone this into our Jenkins jobs, and we'll use that to do the checks for us. Okay, so why don't we use RSpec or Beaker? Okay. How many people know about Beaker?
That's the one I was trying to remember earlier.
Beaker, okay. So RSpec is pretty good, but there's the difference between testing whether a Puppet catalog compiles, which is what RSpec does. Beaker is more like integration testing. So Beaker is a really nice tool where it'll spin up a VM, try and run Puppet against it, and then you can do tests such as if you're using a MySQL module, for example. It'll spin up a Vagrant instance, run the module against it, and test, does the MySQL database exist? Is it listening on a port? And whatever else you want to test it. We started to do some of this stuff. We ran into issues with the Beaker code wasn't very well documented at the time. It seems to have been progressing very well because Beaker happens to be what Puppet Labs uses internally to test their modules. So we're kind of kind of in a holding pattern on that, but it's definitely something worth looking into if you're interested in doing integration testing on your Puppet code. Okay, so the next stage, where we're finally at, what my talk is supposed to be about, is continuous deployment. And the reason we can do continuous deployment is because we've done all those checkpoints along the way. We've either run the checks on the command line as we've written code. If those have passed, our editors maybe flag stuff. If the editor hasn't flagged anything, the pre-transaction commit on the SCM tool should have picked up an error. If those missed it, or if there's a business logic problem, the peer review should have picked it up. And if all those tests have passed and we've merged it from the dev repo to the prod repo, and those transactions have worked fine, the Jenkins tests have worked fine, we're pretty confident that the test is going to work. So we're confident in doing the trunk-based deployment. So at this point, we kind of cheat. We use the VCS repo module, which is a Puppet-supported module now. You pretty much point to a directory that you want to have your repo checked out to. You can use a different provider. HG is short for Mercurial. You can use Git, Subversion, Clearcase if you're into pain. And you point to your source of where you check it out. So what we do is we have mcollective at the end of the Jenkins build pretty much just kick off this stub on all of our Puppet masters. So we use mcollective to say, find all of our Puppet masters, and for each of them, run Puppet and apply this. And wait for it to go through, and the code is automatically deployed. So this is great because prior to doing this, our process had to be, well, you had to be in a certain group to commit code. You had to be in a certain group to actually log onto the machine, that's the Puppet master, and had to be in a certain group to check out the code. Well, now, if you commit the code and it passes all the tests, it does it for you. So we don't have to rely on only our operations team to do Puppet code deployments. Pretty much any developer that can commit to the repo can get something pushed out to production, which makes it a lot quicker to get things out the door. All right, so review time. The main idea is catch your mistakes early. The earlier you catch them, the easier it is to fix them. If you wait too long to catch your mistakes, you're going to have a hard time fixing things. You might have to undo some things. Automate as much as possible, but still don't let the robots take over. Keep them in check. You want to make sure that there's a human making sure that things look right, that the errors you're getting are kind of point you in the right direction, you can fix them. And also making sure that the business logic is right. Just because something is valid in Puppet doesn't mean it's the right thing to do. And for us, trunk-based deployments was a big win. Again, you kind of have to use your best judgment with your development practices on whether trunk-based deployments or something such as R10K is a better method for you. Okay, so any questions? Got one last one. Someone ask a question. Okay.
This thing's straight up dead, so.
I'll repeat your question.
So I'm curious, since you're doing continuous deployment, how much production monitoring do you have to know if your most recent deployment is causing issues?
The question was, since you're doing continuous deployment, how much monitoring do we have to make sure that the deployments aren't causing issues? A lot. We use Zabbix internally, and we monitor everything from ping times to response times to our services up or down. We use the open source version of the Puppet dashboard so we can see if things start failing. We actually have a custom report that if a machine is failing, a Puppet run, which alerts our, we use HipChat internally, so it sends us all an instant message about, hey, I'm failing, here's the error, and points to the Puppet dashboard. I guess that's the main way we do it.
Do you have it automatically stop the deploying and back it out?
No, we don't do that. We rely on, we have some tools that will actually stop Puppet runs across the board. We use Uncollect to disable Puppet across the board so that Once we see like maybe 1 or 2 machines come in with errors, we'll hit the emergency stop button and stop up it across the board, dig in, see why is it causing an error, and then we'll do another push essentially. We're lucky that we don't have any single points of failure in our stack. If we have 1 or 2 hosts fail, that's fine, we can handle that. Our load balancers will deal with it. And most of the stuff we're doing is really infrastructure stuff. We don't deploy our code with Puppet. That's a whole separate deploy process. So if we're breaking something, it's usually we're breaking our own infrastructure and we're going to know it pretty quickly. Any other questions?
See if this is working.
What are you using to monitor for scale? So to auto scale, or do you do auto scaling of machines and using Puppet in that sense?
No, we don't do any auto scaling. We have bare metal everything. And that was the main reason we needed a system like this, because when we'll do a sharding model, that's how we scale. We'll bring up what we call a shard, and a shard is about 16 various bare metal servers. So usually bringing up a new shard involves making a new YAML config file with all the settings for that. So scaling is go put in a big purchase order for new hardware.
So they're on, and when the machines are on, you're not pulling them down based on those ratings.
Right. Pretty much one of the reasons we went to bare metal is that we hit them pretty hard, doing 500 emails at a time. That's just the delivery process. There's also our web front end process and database backend. So they're all hitting it pretty hard. So we have pretty good metrics of figuring out how quickly it's going to scale, and we'll buy the hardware before it gets to that point.
I work for a cloud provider, so for a lot of our customers are interested in auto scaling and then using Puppet to configure what has scaled. And so still trying to find the right mix that does that very elegantly.
Okay.
We're force fitting some things, but still seeing what's working well out there.
Just because he didn't have the mic, the question was, he works for a cloud development provider and trying to figure out how to get Puppet to run against instances as they scale up afterwards. Come talk to me afterwards. We do some interesting stuff in how we scale the bare metal, like once we rack it, how it shows up and how it gets auto-provisioned. I think the way we do things would work just as well in cloud as bare metal.
I had a question about why you use multiple Puppet masters.
I lied, we don't. we only have 1 Puppet Master right now. We are reaching the limits of it. Where I worked previously, we did have multiple Puppet Masters, so I was doing a little bit of future proofing for this, so that when we get to the point where we do need to have multiple Puppet Masters, we don't need to change the process at all.
What is your rationale for multiple Puppet masters then, both at your previous and why you're planning for it now?
Once you get to a certain scale of how many hosts you're checking into a Puppet Master, things start really slowing down. So your compile times get slower. Talking to Puppet DB slows down. Just the Puppet Master itself gets very CPU bound. And so you can do things such as have stuff run out of cron so they don't all hit at the same time. The big thing I've run into in the past is the thundering herd idea. So that if you have systems checking in every 30 minutes, eventually you reach a point in time where everything is checking in at the same time. So when you have 1,000 hosts all wanting the catalog right now and they're going to time out if they don't get an answer in 30 seconds, then that's when you're running into problems.
Yeah? Oh.
Oh, my coworker wants to harass me.
Are you hiring?
Yes. Are you leaving? Yes, we are hiring. We have several jobs posted on MailChimp.com. I would love to have anybody come work for us. We're going through explosive growth, which is very exciting times in the company. The phrase "may you live in interesting times" definitely applies to our company right now. So if you're interested in this type of stuff, scaling up things in a bare metal environment, definitely come talk to me and my team who's back there harassing me, and apply. If there's no more questions, or if there are, definitely feel free to talk to me afterwards. Here's my contact information. The slides should be on SlideShare soon if they're not now. The sources for the slides are here. The reason I post the sources to the slides is that the URLs in the PDF didn't really translate very well, so you have to get the source, unfortunately.
Excellent. Thank you so much, Bill.